I'm Dr. Jamal Young, and I will present our SCRA presentation, The Impact of STEM Research in Urban Education, a Citation Analysis. National reports consistently cite the importance of science, technology, engineering, and mathematics in the context of future success of the United States economy and global competitiveness. However, these discussions often exclude urban environments as potential nuclei for STEM development and innovation. As a result, it is important to examine the academic impact of urban STEM education through the lens of high quality scholarly metrics. Article citations are arguably the purest mechanism to evaluate the scholarly impact of research in the field. Thus, the purpose of this study is twofold. First, we examine the impact of urban education journals because they are the mechanism through which articles of interest are published. The impact of STEM research published within urban education journals is based on the citations that each article published within these journals receives. Second, we examine the factors that influence the impact of STEM research in urban education by examining citation patterns across journals, methods, STEM foci, urban typology, and time. Two research questions guided this study. First, what are the citation trends of STEM research published in top three urban education research journals? Urban Education, Education and Urban Society, and the Urban Review. The second research question states as how are citation rates influenced by journal venue, methodological approach, STEM foci, and time? Although there are a plethora of measures of research impact, the importance of a publication is often measured by citation frequency. Publication impact is measured by the influence of one's work on subsequent publications. That is, the influence of a publication is related to the citation of that paper in future studies. Put another way, the impact that a publication has on a field is specifically measured by how often scholars and the broader community solicit that work to inform research and practice. Based on this notion, this study is guided by the normative theory of citation, which holds that citations are influenced by a combination of perceived worth and the article's intellectual, methodological, or topical content. Hence, our focus on journals, methods, STEM foci, urban typology, and time. The method for this study. An extensive search of three urban education journals was conducted to identify all articles related to STEM education. A total of 49 articles were included in this study and were obtained through a keyword search conducted through PsycInfo and ERIC, using the terms derived from the categories described in the STEM Education Act of 2015. These included, for instance, science, technology, engineering, mathematics, computer science, informal learning, out of school time, etc. Articles for the present citation analysis were only reviewed if they were published between 2014 and 2020. After articles were selected, they were coded and categorized according to the methodological paradigm, whether that's qualitative, quantitative, or mixed. Next, the category of STEM content focus in the three journals was identified based on categories provided by the STEM Education Act of 2015. If more than one category was used, then the article was categorized by the corresponding letters of the STEM acronym that were included. For example, science and math was categorized as SM. In addition, the following citation information for each article was collected: the number of Google Scholar citations, the number of Google Scholar citations excluding author self citations, and the number of Google Scholar citations excluding journal self citations. These data were cleaned and uploaded to IBM SPSS version 22 for further analysis. To assess the research trends across the three urban education journals, we first examined the descriptive statistics for the mean number of citations before and after normalization to account for the vintage effect. The vintage effect is primarily looking at the fact that older articles will typically have more citations, so we definitely wanted to account for that. Then we plotted the cumulative number of citations over time to visually assess the vintage effect. Next, we conducted a regression analysis to assess the influence of journal venue, research methodology, STEM foci, urban typology, and the time on the number of citations. After we remove one outlier, the total number of citations across journals, excluding author self-citations, was 571. The mean number of citations was 11.89 with a standard deviation of 12.92. The individual number of citations per article ranged from 0 to 54. Urban Education had the most citations with 351, followed by Education and Urban Society with 136, and Urban Review with 84. Due to the different number of STEM articles published in each journal from 2014 to 2019, it is important to also look at the mean citations. The mean number of citations showed a slightly different pattern, with Education and Urban Society accruing a mean of 13.6 citations with a standard deviation of 14.78, followed by Urban Education with a mean of 13.5 citations with a standard deviation of 13.78, and Urban Review with a mean of 7 citations and a standard deviation of 8.3. To account for the Ventures effect, we also normalized the number of citations by dividing the number of years the article appeared in the journal. This resulted in the same ordering of the journals. The mean normalized citations for non-quantitative research was 4.64 with a standard deviation of 5.9. And this was higher than the number of citations for quantitative research, which only received 2.94 citations on average with a standard deviation of 3.04 in urban education journals. Articles that presented integrated multiple STEM content areas rather than a specific content focus were cited more often on normalized mean citations. So these received 5.68 citations on average with a standard deviation of 4.12, and while those non-integrated citations only received a 3.8 mean citations with standard deviation of 4.34. Based on the adjusted R-squared for the regression analysis, the present model explained approximately 4.27% of the variance in citation frequencies for STEM education research published in urban education journals. Despite the observed differences in the number of citations across urban education journals, the regression analysis results indicated that the differences were not statistically significantly different. Additionally, urban typology, methodological paradigm, and the time were not statistically significant predictors of citation frequency. However, STEM integration was a statistically significant predictor of citation frequency. Finally, there was not a statistically significant integration effect between urban education or education and urban society and time. This lack of an interaction effect indicates that frequency of citations for articles published in different urban education journals did not grow at statistically significantly different rates from 2014 through 2019. In conclusion, over the last 2 decades, STEM-related studies have become popular lines of inquiry for developing policies and practices within the field of education. Yet what remains elusive is the cross-disciplinary impact of STEM education research. This study contributes to an empirically and practically useful characterization of the impact of STEM-related research within urban education and provides insights into the structural relationship between pertinent study-related elements such as STEM content area focus and urban typology on research impact. These data will help to inform research practice and policy as the impact of research in the field influences trends in government spending on research funding decisions. Thank you. So again, I'm Dr. Jamal Young from Texas A&M University. My colleagues could not be here with me, Michael Rudd and Jamima Young, but they also contributed to this presentation. And if you'd like to contact us, please feel free to using the following information. And thank you again for viewing our presentation.